Hello, and welcome to part 3 of the video series on the LinuxKI toolset. In this session, we'll discuss how LinuxKI works, how to collect a LinuxKI trace dump, and how to generate the LinuxKI reports. Remember from part 1 of the video series, LinuxKI is a trace-based tool to microanalyze system behavior. Many trace-based tools can be very difficult to install and use. The users may have to decide where to trace or how to drill down on a large amount of data to understand the performance issues. But for a performance tool to be useful, it needs to be easy to install and easy to use. LinuxKI uses predefined trace points in the kernel in strategic code paths to collect the trace data. Originally, LinuxKI used ftrace and harvested the binary trace data from the per CPU trace buffers, which were exposed through the debug file system. However, ftrace had some limitations and was missing some key features we desired. So HPE developed a new Linux kernel tracing module called LinuxKI, which is short for LinuxKI. The LinuxKI tracing module is the default tracing module used. However, trace data can still be collected with ftrace if needed. The first step in collecting data is to log in as root and execute the LinuxKI script while the performance issue is occurring. The script will do all the work for you. It will insert the LinuxKI DLKM into the kernel, then uses the KI info program to enable the trace points, initiate the tracing, and dump the raw trace buffers to disk. By default, the trace period will be 20 seconds. Once the trace is complete, the LinuxKI script will remove the LinuxKI DLKM from the kernel and collect some supplemental system information and configuration data. Finally, it compresses all the information into a single gzip tar file with the host name and timestamp embedded in the file name. Next, the KI tar file can be copied to another system, or it could be analyzed on the current system. While this is an optional step, it's sometimes useful to analyze the trace data on a system that's not experiencing the performance issue. Also, the engineer that analyzes the trace data does not have to have access to the system where the trace was taken. On the server where the KI data is being analyzed, simply execute the KI all script to process the data and generate the LinuxKI reports. The -R option uses the host name and the timestamp to create a subdirectory structure which is useful when analyzing multiple trace dumps. The KI all script will execute the KI info program to generate a detailed ASCII trace file along with a number of LinuxKI reports, which provide a variety of statistics about the trace data. You'll get detailed analysis regarding every task that executed during the 20-second trace, along with CPU statistics, disk I/O statistics, network statistics, and much more. We'll explore these reports in a future video session. In part 2 of the LinuxKI video series, we downloaded and installed the LinuxKI toolset. In this demo, we'll collect the trace data using the LinuxKI script and then generate the LinuxKI reports using the KI all script. The data will be collected in your current working directory, so you'll want to be sure there's plenty of free space available. The size of the trace depends on the size of the system and activity. It can be 50 megabytes for a 2-socket server with 48 cores, or 5 gigabytes for a busy 32-socket server with 896 cores. For best results, I recommend collecting the trace in memory using /dev/shm. This way, it doesn't generate additional I/O load on the server, which may already be experiencing I/O performance issues. Just be sure you have plenty of memory available so you don't run out of memory while collecting the trace. Simply execute the LinuxKI script to collect data for 20 seconds. If the performance issue is occurring during the trace period, we have a good probability of identifying or narrowing down the issue. While the trace period is only 20 seconds, the LinuxKI script may run for a minute or two while it collects other system information. Once the LinuxKI script completes, you'll find the KI tar file in your directory. At this point, the file can be moved to permanent storage or to another server. If you use /dev/shm, be sure to move the KI file to permanent storage so it doesn't consume memory. For this test, we'll simply process the data in the current directory. The KI all script will do all the work. It will extract the data and generate the reports. The -R option is used to create the subdirectory structure. And that's it. The trace data has now been collected and processed. We can now list the files in the directory using the host name and the timestamp. The ASCII trace file will have the file name of KI followed by the timestamp. The files ending in .txt are the LinuxKI reports, and the HTML file is the kparse report, which provides an overview of the trace activity with hyperlinks for navigation. You'll also find some CSV files, and finally, you'll see a lot of supplemental files. Now you're ready to dig into the data, but we'll start looking at that in part 4 of the video series. Just remember, collecting a LinuxKI trace dump and processing it is as easy as 1, 2, 3. Simply log in as root and execute the run KI script, transfer the data if necessary, and execute the KI all script to generate the reports. Be sure to bookmark the LinuxKI wiki page and check for the latest updates and news. And tune in for part 4 of the video series as we start to take a look at the LinuxKI reports. Thank you for watching and see you next time.